In this video, we'll discuss tangent problem, and so which is the motivation of limits. Right? This is basically why do we define limit? So in calculus 3, there are three very important definitions. The first one is that limit. Second one is derivative, and third one derivative. Sorry. And the third one is integral. So that's three key concepts of calculus 1, also calculus 2, and also calculus 3, right? It has many applications. So basically, why do we introduce limit, derivative, and integral? Because in real life, we meet so many problems. How do we solve such problems? That problems motivated the definition of limit or derivative or integrals. So it has many applications. So let's see one of the motivation of limit, right? Why do we define limit? How does limit help us to understand and solve the tangent problem? So let's see a quick example here, right? So we, instead of use a general function, we use a fixed function here. We have an example here. So let's use one of our elementary functions, right? Y equal to x squared, right? You can sketch the graph of such a function. So if you have, this is our x axis, this is our y axis, right? You can plug in all the x values and y values which satisfy y equal to x squared, right? If you have x is 0, y is 0, x is 1, y is 1, x is 2, y is 4, right? Just plug in all the x values and into our function, we get all the y value. So the graph of this function is basically equal to all the x, y's such that y equal to x squared, right? So that is basically how do we understand it, right? Let's try to sketch the graph. So passing through 0, 0 and 1, 1, negative 1. So it's a parabola, right? Opens up. Let's fix one point because in some situations, we want to know what's the tangent line, right? The equation of tangent line. Fix x equal to 1, right? So this is 1 here. Fix x equal to 1 here. You have a point on the curve, which is 1, 1, right? This is our point. Let's call that P, right? Our point P here is x value is 1, y value is 1, right? So we want to sketch the tangent line. Tangent line means touching the blue curve, but never intersect it, right? So this is our tangent line here. So the natural question here is, what is the equation of such a tangent line, right? So our question here is, we want to find an equation of the tangent line to the curve. The curve is given by the equation, which is y equal to x squared. And at the point, which is P, and P is 1, 1. Right? So that's our natural question, right? You can do consider other curves and different points, but basically the question here is giving an arbitrary curve. If the curve has a tangent line, we are looking for the tangent line equation, right? So that's what we want to solve. And how do we solve it, right? So recall that if you are looking for a line equation, right? A good way to do that for sure is a point slope form, right? So if you have a line here with slope, let's call that M0, right? And passing a point which is x0, y0. So if you have a line, slope, it should be slope, slope is m0 and passing through y0, x0, y0, then the line equation is given by y minus y0 equal to m0 x minus x0, right? So that's a line equation if you are given the slope of the line and also you are given 1 point in the line, right? So that's how do we get our line equation. And here, so here we are given 1 point, which is 1, 1, but we don't know the slope. Now, how do we figure out slope? Normally, if you want to figure out slope, you need 2 points. The difference of y value over difference of x value, you get the slope, right? But here we don't have the other point, right? Now the question here is how do we get our slope? Okay, so we don't have the actual point, but we do have other points on the curve. So you can always sketch a secant line. So let's use red for our secant line here. If you choose an arbitrary point Q here, and Q here, the coordinate should be x, and the y value for this non-point here is basically x0, right? For such a point, we know the slope of the red line, right? So we just consider the secant line PQ, right? The slope of PQ is okay. That's easy, right? The slope of PQ, that's easy. Let's use a notation for that is mx because that's corresponding to q. Q is the coordinates for the x coordinate for q is x, right? Let's call that mx, right? Mx is the difference of y value over the difference of x value, right? So that is the slope of PQ, right? But recall that we are looking for the slope of the tangent line. This for sure is not the tangent line, but if you think deeper, right? If you consider PQ, you can move your Q to P, right? So you can see that the slope of the tangent line, right, is the limiting of the slope of PQ as x here, as q here, goes to P, right? And think about that. If you have starting from here, you get another one, you get getting closer, right? Slope is getting closer for sure. You get this one here, slope is also getting closer. So as your Q here getting closer and closer to P, right? The slope of the red line, which is our secant line, right, is getting closer and closer to the slope of the tangent line. So this is the tangent line. This collection here are the secant lines, right? So as x getting closer and closer to 1, then the slope of the secant line is getting closer and closer to the slope of the tangent line, right? So that's how do we force our Q to the value of 1, because as right, Q goes to P means X is getting closer and closer to 1. I dot E X goes to 1, right? So let's try to figure out what is the limit number as X getting closer and closer to 1. You cannot plug in 1 because Y, if you plug in 1, you get 0 over 0, right? So that's impossible. So let's try to do that. So let's see that. So let's use X goes to 1, right? This notation here to represent X goes to 1, right? This is same as X goes to 1, right? Which means getting closer and closer, right? And so how do we get closer and closer, right? Let's try numbers, right? There are two sides. X goes to 1 and goes to two sides. So if you have the value X to be 0 from left side, 0 0.9, 0 0.99, 0 0.99, and 9, you calculate mx, which is x squared minus 1 over x minus 1. This will be 1.9, 1.99, and 1.999, right? If you have x on the right side, because as x getting closer and closer to 1, as I mentioned, there are two directions, on the left side of 1, on the right side of 1, right? So you can choose 1.1, 1.01, 1.001, right? The value of mx will be 2.1, 2.01, and 2.001, right? You can see that, right? Not hard to see that. This limit, right, mx is getting closer and closer to 2, right? So by the observation, we know that as x goes to 2, right? Or not goes to 1, sorry. As x goes to 1, 1 here, then mx goes to 2. So now the problem of the tangent, now the tangent problem is solved, right? So the equation of the tangent line to y equal to x squared at the point, which is P, which is 1, 1, is given by y, because you have a point, y minus 1, y value of the point is 1, and equal to slope x minus 1. And so that's the tangent line equation here for the to the curve at the given point, right? You can see that this is the idea of introducing limit, right? Sometimes you cannot solve the problem directly. So instead of try to do a direct solution, we need to do some approximations, right? Because you're starting from here, you have an approximation. And as x or our point Q getting closer and closer to P, you get better and better approximation. So eventually you take the limiting process, you get the exact solution. So this is the idea of limit.